How's it going, guys? Today in this video, we're going to be going over module 5.1. I guess in your notes now it's going to say day 3. It's day 2 of actual lectures. So what we're going to be learning today is how we can write a second-degree equation with two variables into a standard form of an equation. All right, a standard form of a parabola. So we can use something like this ax squared plus by squared plus cx plus dy plus e equals 0, or really with actual numbers, x squared plus 2x minus y squared minus 4y plus 12, something in that nature, something like that. We're going to teach you guys how, in this video, I'm going to show you how to go from that form into our standard form of a parabola, so we can actually graph it and figure out the properties of that parabola. All right. So in your notes, I know it says vertex form, so go ahead and write what's in red on this page right here, because we're not going to be using vertex form of the parabola. We're going to be using standard form. So go ahead and rewrite, or not rewrite, but write what's in red on your notes. Make sure you have this down, because this is the form we're going to be using in this module. So what we're going to do is we're really going to do completing the square. We're going to isolate the square term. We're going to move everything else to the other side, and then we're going to do completing the square with the square term, and we'll end up factoring out the other side. We'll see. Actually, it's a little weird to talk about it right here. So let's go ahead and do an example. I'm going to show you exactly what we're supposed to be doing. So in number 1, we have x squared minus 4x minus 4y plus 12 equals 0. So when I say we want to isolate the square term, first we need to figure out what these square terms are going to be. Our x is being squared, to the x is the square term. So we're going to isolate it on one side, and it's 4y and 12. I'm going to move to the other side. So I get positive 4y minus 12. And once I do that, I'm going to do completing the square, or I'm going to complete the square with the square term. The x's are being squared, so that's what I'm going to do completing the square with. So my b is negative 4. So I divide by 2. So negative 4 divided by 2, all squared, is a positive 4. If I add 4 to the left side, I have to add 4 to the right side. All right, this should all be reviewed. We do complete the square for like 2-3 modules now. All right, so then from here, this part right here is going to factor out into x plus b over 2, all of that squared, or really just x minus 2, since our b is negative 2. Our b is negative 4, and negative 4 divided by 2 is negative 2. So you get x minus 2 all squared equals 4y minus 8. But remember what our standard form of the equation is. It's in the form x minus h squared equals 4p y minus k. See, we don't have any coefficient in front of that y. So that means this 4 right here, we need to factor that out. We don't want that in our equation. We want to factor it out. We do not want a coefficient in front of our y. So we're going to factor out that 4 to get x minus 2 squared equals 4 y minus 2. So factor out that 4. That's what you get. And it's not vertex form. It's going to be standard form. Because anytime you see vertex form, just rewrite it to standard. So our 4p, in this case, that's going to be 4. So that means our p is 1. So right here in this first blank, our p is 1. And since our x squared is being squared, I know I'm going to be vertical, because if x is being squared, we're opening up or down. It's like the equation y equals x squared. We know that'll open up or down. Same thing here. Our x is being squared, so we know we're opening vertically or up and down. Our 4p is positive, and since our 4p or our p value is positive, we're going to open up. And our vertex is going to be 2, 2. Right, that's our hk term from the equation, so we get 2, 2. So for our focus and directrix, instead of trying to figuring it out with the p-value and the vertex and trying to think about it all in my head, I'm just going to go ahead and graph it. It just makes it much easier, much clearer to see everything. So just, if you have a graph, or even if you don't have a graph, make one. Just graph it, make your life that much easier. So our vertex is at 2, 2. And my focus, I know I'm going to be p values up from the vertex. I know that because the focus is always inside of the opening of the problem. So if the parabola opens up, that means my focus will be p above the vertex. So I go one p-value above the vertex, or just go one value up, and I'm at 2, positive 3. Remember, the distance from the vertex to the focus is always p, and the distance from the vertex to the directrix is also going to be p. And the focus is always inside of the opening of the parabola. So that's why I know I go up from the vertex. And then for my directrix, I go one p-value down from the vertex, and that's a line. The directrix is always going to be a line. So I get the equation y equals 1. Right, every single point on that dashed line has a y value of 1, so we call that line the y equals 1. The axis of symmetry, well, actually before we go to axis of symmetry, let's go ahead and finish up our graph. So from here, we go 2 p-values to the right and 2 p-values to the left of the focus, or in other words, 2 to the right, 2 to the left, and our parabola will look something like that. Not the prettiest parabola, but it's going to look something like that. In our axis of symmetry, since our x term is being squared, or we're a vertical parabola, it's going to be x equals h, or in this case, x equals 2. The focal width is the absolute value for p, so in this case, it'll be just 4. And we're not bothering with endpoints, so don't do that. All right? So really, the only new part that we're learning in this video is this part on the left with the completing the square. That's the new part, and we've already kind of touched on that. We're just combining 2 new skills, or 2 skills we've already known, into one problem. So let's go on. On number 2, we have y squared plus 2x plus 8y plus 18 equals 0. In this case, our y term is one being squared, so I'm going to isolate that to the left side. And I get y squared plus 8y plus some blank. You got to do completing the square. I know that now. And I'm going to move that 2x and the 18 to the other side. So I get minus 2x minus 18. All right. So I do completing the square. And I do my b value here is going to be 8. I know it's a little weird seeing the y's instead of x's, but it's going to act the same exact way. My b value is 8. So 8 divided by 2 is 4, and 4 squared is 16. So add 16 to the left side, and I'll add 16 to the right side. And then from here, I'm going to do completing the square on this left side. Remember, it's still going to be y plus b over 2, all of that squared. My b is 8. 8 divided by 2 is 4. So y plus 4 all squared will equal negative 2x minus 2. Negative 18 plus 16 is negative 2. And then I'm going to factor out that negative 2 because, again, we're in the form y minus k. You write that a little nicer. Y minus k all squared equals 4p. 4p multiplied by x minus h. There we go. That's the form we're in. And same thing as before, I don't want a coefficient in front of the x. So I don't want that negative 2 in front of the x value. So I'm going to factor it out. And when I do, I get y plus 4 all squared equals negative 2 x plus 1. So here, my 4p is a negative 2, or my p is negative 1/2. So my p is negative 1/2. And if my p is negative, and I know I'm going to open horizontally because my y term is the one being squared. If my y is being squared, that means I'm going to open horizontally. We're squaring something we're not used to seeing being squared. So we're going to open up a way we're not used to seeing the parabola open up, right? We never see y's being squared. We never see parabolas opening left and right. So they go together. So from here, I know I'm also going to open left now because my p is negative. So I'm going to open up to the negative side. I'm opening horizontally. So I'm going to open it horizontally to the negative side, which will be to the left. My vertex is negative 1, negative 4. If my focus is directrix, again, I'm not going to try to figure this out with math or my p values. I'm just going to plug into the equation. So This graph is kind of weird. We have a weird p-value of 1/2. So I'm going to make this graph go up by 1/2. So actually, instead of going up by 1/2, I'm going to go up by 1 every 2. So 1 there, 2 there, and 3 there. 1 here, 2 there, 3 there, 4 there, and 5 here. These should be negative, shouldn't they? There we go. All right. So that's what I'm doing. I'm going to go up by 1 every 2 just because I'm dealing with halves, and it's going to get really crowded if I don't do this otherwise. So I have my vertex at -1, -4. So right here. All right. So -1, -4 is right there. So actually stay consistent and leave my vertex in blue. So -1, -4 right there. And now my focus will be one p-value to the left. It's going to be one p-value towards the direction that I'm opening at. So I open to the left. So go 1/2 to the left. So I'll be right there. So my focus is at -1.5, -4. And then my directrix will be one p-value to the opposite side. So in this case, it'll be x equals, oh sorry, y, yeah, x equals -1. My directrix is x equals -1/2. From here, I can go ahead and graph my function. I go, for my focus, I go up 2p and down 2p. So I go up 1, down 1. So it'll be right here and right here. And my parabola will look something like that. All right. Some axis of symmetry, my y is being squared, so it's going to turn into form y equals k. So y equals -1, or not -1, -4. Y equals -4. There we go. My focal width is the absolute value of 4p. My 4p is -2. The absolute value of that is +2. And we're not doing anything else. All right. So go ahead and try the next two on your own. Pause the video, and I'll show the answers to those in a bit. It is good practice to kind of understand what we're doing here and to be able to double check the work with mine. All right. This is what you should have got for number 3. So if you do complete the square, you should have got to y minus 2 all squared equals 12x minus 60. You have to factor out that 12 because we don't want a coefficient in front of x. So you factor out the 12, you're left with y minus 2 all squared equals 12 times x minus 5. Our 4p is 12, so that means our p is equal to 3. So our p is 3. We open horizontally. I know that because my y term is being squared. We open to the right. My vertex is 5, 2, and then from the vertex, I go right. I go towards the opening, which is right by p. So go over to the right from the vertex 3 units, and then find the directrix. Go to the left by 3. I get y comma 2 for the focus. So I have y8 comma 2 for the focus. The directrix is x equals 2. In the axis of symmetry, it would be y equals k, or in this case, y equals 2. The focal width or the lattice rectum, that's 4p. So 4p will equal 12. And if you haven't done number 4, pause it, or maybe you did, or yeah, if you didn't do number 4 yet, just pause the video, try it out now. And this is what you should have got for number 4. Same thing, do complete the square on the left side over the x's, since the x is being squared. And you end up getting x plus 4 all squared equals 16 times y plus 4. Because we want a coefficient of 1 in front of the y, so you have to factor out that 16. Our p-value ends up being 4, since 4p equals 16. We open up. I know that because my p is positive and my x is the term being squared. My vertex is -4, -4. If I go from my vertex and I go up towards the opening by a p-value of 4, I end up at -4, 0. And if I go from the vertex down 4, I get to the line y equals -8. My axis of symmetry will be x equals h, or in this case, x equals -4. My focal width is the absolute value of 4p. My 4p is 16. And the absolute value of that is still just 16. So my focal width is going to be 16. All right. Just keep on going. Now, on this case here, we're going to be figuring out how to write an equation of Bravo, where we're just giving you a few bits of information. So this stuff right here, all it's really saying is we're going to check if the directrix is a horizontal or vertical line. Then we're going to figure out what kind of parabola we have. We'll sketch it. Once you sketch it, we can kind of figure out everything from there, right? The biggest thing to always remember, I think I said this in the last video too, the vertex is in the middle between the directrix and the focus. The vertex is always right in the middle between the two. So when you sketch your graph, you can pretty much figure out everything else you need to know. All right. And then once you sketch the graph, you figure out your vertex. You can, in one of the focus or the directrix, you can figure out what your p-value is, and then you have all the equation you need for there. So on number 1, we're asked to find the equation of a parabola in standard form with a focus of 3, 4 and a directrix of y equals 0. Honestly, I'm not going to even try to figure out which way I'm opening from here, because we're going to sketch it anyway. So save yourself the little headache and just sketch everything. I have a focus at 3, 4. So at 3, 4, I'll be right here. That's my focus. I have a directrix at y equals 0. That's going to be the x-axis line right here. Every point on that line has a y value of 0. So that's what we call it, the y equals 0 line. And the distance from the focus to the directrix is going to be a total of 4. So that means the distance from either the focus or the directrix to the vertex will be 2. So I go down 2, and I'm at 3, 2. This right here is my vertex, and I know that because the distance from here is a p-value of 2, and this also has to be a p-value of 2. So the distance from this vertex we found to the focus and the directrix is the same, which is a p-value of 2. So that's how I know my vertex is actually 3, 2, because the distance from the vertex to the focus is the same as the distance from the vertex to the directrix. So I know my p is 2. That means my 4p is going to be 8. Now I need to figure out which equation I'm going to use, the vertical one or the horizontal. Remember, the parabola will always open up into the focus. So if my focus is above, I know I'm going to open up towards the focus. So I know my 4p is going to be positive because I'm opening upwards into the focus. And I also know I'm opening vertically or I'm opening up. So a positive p-value with the vertical standard form. So I get x minus 3 all squared. Since I'm using this form right here on the top left corner of the screen, and that'll equal my 4p, which we set to 8. Since our p is 2, multiply that by 4 gives you 8. Multiply it by y minus k, or y minus 2. So this right here is our equation, and the answer to this problem. We don't need to sketch an accurate graph because it doesn't matter. All they're asking us to do is just find the equation, and that's the equation right there. Number 2, I actually wanted you guys to do it on your own. Forgot that. So just go ahead and pause the video, try it out on your own. Same for number 3 and number 4, and well, I'll go to the next screen and we'll go over it also. All right, I'm sure you already saw it, but this we should go for number 2. We're going to find the equation of a parabola in standard form with a vertex of 3, 2 and a focus of 1, 2. So they already give us the vertex. I already know my HK point is going to be. All I need to figure out now is what my 4p is going to be, and what my if my 4p is going to be positive or negative, and which equation I'm going to use. So I'm told my vertex, which is at 3, 2, and my focus at 1, 2. I didn't actually need to find my directrix because they already have my focus. I already know which way I'm going to open. So from the vertex they gave us at 3, 2, the point in blue, and my focus at 1, 2, which is to the left of it, I know I'm going to open to the left. I know that because my focus is to the left, so I know I'm going to open horizontally, and essentially add this here to the left. I know that, and also the distance from the vertex to the focus is 2, so I know my p-value is going to be 2, so 4p will be 8. So from here, I already have everything I need. Should have 4p should be -8. Sorry about that, because we're opening to the left, so it'll be negative. So from here, I know I'm going to use the horizontal standard form, so it'll be the y squared version. So you have y minus 2 all squared, or y minus my k value, equals my 4p, which is -8, times x minus 3. All right, so you're going to get this one right. Try number 3 again, and we'll go to it in the next 3 in a bit. All right, this is what you should have for number 3. See, this one, I didn't even need to actually wrap the function because I didn't really care for it. Because I already know my directrix to the left of it, so I'm going to open it to the right. So my vertex, we're given as 3, -3 is the blue point right there. The directrix at x equals 2. And I know my p-value, because the distance from the vertex to the directrix is 1. So I don't even really need to sketch it, because I know if my directrix is to the left of the vertex, I'm going to open it to the right away from it. So I'm going to open up this way. So I don't even need to find my focus. I don't care for it. It's not going to do me any good because I have my p-value, which is going to be a +1. So my 4p will be a +4. I know I'm positive because I'm opening to the right. I'm opening to the positive numbers. And I'm going to use the y squared version of the equation because I'm opening horizontally. So I get y minus k, or y plus 3, all squared, equals 4 times x minus 3. And that's my equation. It's much easier if you always sketch a graph to understand exactly what's happening. If you need to sketch the focus to figure out exactly what's happening, that's perfectly fine. You would have got the focus to be right there at 4, -3. If you need that focus, that's perfectly fine. Just make, as long as you sketch a graph, it'll make it much easier. All right. Now for the last problem that we're going to go through. That'll be example 4. If you haven't done it or you want to try it again, pause the video and give it a shot. And this is what you should have got for number 4. In this one, we're given the focus, the point in black, and the directrix, the line in red. And we can figure out the vertex because the vertex is the point right in the middle of the two. So when you figure out your p-value, since the distance from the directrix to the focus is 8, that's 2p. So that means p will be equal to 4. So we get our vertex to be at 1, +4. That's how you figure it out. It has to be the point right in the middle of the two. From here, I know it's going to be horizontal and opening to the right. I know that because my focus is to the right. So I'm going to open that way. I'm opening to the right. So that means I'm going to be positive, and I'm using the horizontal equation of a parabola. My p is 4, my 4p will be 16. So I get the equation y minus k, or y minus 4 all squared, equals my 4p, which is 16, times x minus h, or x minus 1. All right? And that's pretty much it for the video, guys. 5 and 6 and the mixed review problems, we're leaving that as homework. So go ahead and give that a shot. The answer key will be online, like always, on Canvas if you have any questions.